Programming languages and design concepts. Online presentation series about language principles. Here is our group information. Our group members are D.C. Gunathilaka, D.A.A. Athukorala, R.P.I.L. Rajpaksha, R.M.P.Y.N. Rajpaksha. This is the brief introduction about the online series. This video is containing about several programming principles and how it's going to affect for different programming languages. The principles that we are going to consider are zero, one, infinity principle, syntactic consistency principle, the structure principle, defense in depth principle, impossible error principle, preservation of information principle, automation principle, abstraction principle, security principle, and information hiding principle. Our effort in here is to give you a brief and concise description on each of the above principles. Furthermore, it includes the effect of the principles for programming languages. Now, I would like to pay your attention on our first principle, that is 0, 1, infinity principle. The definition of the 0, 1 infinity principle is the only reasonable numbers in a programming language design are 0, 1 and infinity. Simply, we can say that programmer is not legal to remember much more rules in additional to the original coding grasps. So, always the coder like to keep limited rules in his mind and about the language concepts or the limitations in language itself. Not for the entire logic of the programmer. So he is responsible for develop the coding, but he is not responsible or not well enough practice to remember those bulk of rules inside the language. So this is the simple idea of 0-1 infinity principle. Even you are a developer, you have to define some rules on other than codings. Let it make the ranges and constant limit for a language amount. In Fortran language, some early stage language design is filled with numbers other than 0, 1 and infinity. Since Fortran limitation of 6 characters identifiers. So, in early stages, the coders have to remember those. In this case, Fortran violates this principle. Algol and most newer languages have chosen the infinity option. They support for developer to freely develop his own logic, not getting much more rules and also constraints. So it's facilitated to define much more objects or classes inside the language as memory is available. Because of that, Algol and newly designed languages follow this 0-1 infinity principle. Now, let's have a look on the other principle. Our next principle is syntactic consistency principle. The definition of the syntactic consistency principle is things that look similar should be similar, and things that look different should be different. The idea of above definition is when you're representing about some idea, the different things relevant to that idea should act in different ways. If there is a language which consists with huge variance operations on similar looking syntax, the consistency can't be maintained. The Fortran use of double asterisk notation. It's for experimentation, but if by some mistake, if you remove one asterisk, it's operate on normal multiplication operation. Not only that, Fortran use plus sign for both addition and concatenation. And also the computed goto and assigned goto are easily confused in Fortran. In this course, Fortran violating syntactic consistency principle. The clear idea we can get from the high-level language C. In C, use equal sign for equation and assign values. Plus sign for addition and plus plus for increments. And also minus sign for subtraction and minus minus for decrement. Single asterisk for multiplication and pointer. In this case, C language also violating syntactic consistency principle.